So we're going right here. So you want to be in 1.3 in your homework or in your packet. So go to 1.3, Extrema and End Behavior. So when we talk about extrema, we are going to talk about, like an order pair, the high point or the low point on the graph. Some graphs have both high points and low points. Some graphs will have 2 low points and 1 high point. So you may need to list 3 order pairs. We'll call them relative, min, max. We'll get to all that later in this lesson. And then we'll also talk about the end behavior of a graph, right? So if I have a graph that looks like this, anyone know what that graph is, the equation?
Y goes to positive infinity.
So that'd be y equals x squared. As x goes to infinity, then we say f of x instead of y. You have to list it as f of x. It's annoying but true. And we'll talk about what happens with those graphs as we go. It would go to infinity as well, though. Okay? So we're doing extrema and then end behavior. So graphs can have high and low points when they reach a max or min value. Max or min values are called extrema. The highest point is a max. I'm abbreviating maximum, so you can write max, is totally fine. Remember, if you need to take notes, because I make you take notes in 2 colors, I went down to our supply closet and got a bunch of different colors. If you need to borrow them, you can come give me your phone and borrow a couple colors if you want. Next blank spot is min. So if there are 2 of them, it could be 1 max, 1 min. We call them relative. Oh, the other point I forgot to emphasize up here is that if there's just 1 min, we'll do max first. So max would look like this. This graph would be negative x squared. And it's called an absolute max because there's only 1 maximum point. Okay? If the graph is a normal parabola, right side up, that would be positive x squared. And that graph would have a min. There's only 1. That's why it's absolute. Okay? So absolute means there's only 1. Relative means there's 1 of each. Or there could be 2 of each, 3 of each, whatever. There could be 2 mins and 1 max. We'll have all sorts of stuff that happens. Next blank spot down is also relative. You can have relative, min, or max. So when we're talking about extrema, we're talking about max or min. So it's good just because extrema is a word you haven't seen before. You're not sure what it means, and now you know it's max or min. If we say extrema, right, you're talking max or min. So if we look at this graph on the left side of example 1, does it have a max or a min? And what is that order pair right here? Look on your graph and count it out. 0 what? 0, negative 5. So we would say absolute min at 0, negative 5. I'm going to abbreviate. You too, if I abbreviate, you can abbreviate. Okay? You just got to know what it means, right? So now on this second one, right over here, they're going to be relative because we have 1 of each. So it's not absolute anymore, right? Because there's a min and a max on this. So as we look at this graph, what's this maximum point right here? This one right here, it goes by 2, so negative 2, 8. Okay? So relative max at negative 2, 8. I'm going to color code this. So relative max at negative 2, comma 8. And then right here, I have a low point in the graph, or a relative min. So I'm going to write relative min and tell me what that order pair is. Is it 0, 4 or 4, 0? 0, 4, right? 0 on X, 4 up on Y. Remember, an order pair is always in XY order. Okay? So if you get mixed up, just make sure you have it in XY order and you're good. How about if I wrote this on a test as 4, 0, how many points out of 4 do you think I'd take off? All? Definitely not. No. Because what did you just made one little mistake, right? You just switched them. I'd probably take a point out of 4 off. Like, you know what you're talking about. You would have told me it's called a relative min, and you just would have switched these. That's not a huge mistake, right? It's wrong, yes, you deserve to lose some points, but I'd take 1 out of 4 off. If you got this one right, like I would think of this as 1 point, this is my second point, that's my third point, it's my fourth point, so I'd take 1 out of the 4 off. Make sense? First and then second.
It's called the relative min because it's the lowest of the dip, but it still goes down lower with it keeps going down infinitely. But it's the lowest part of the dip, right?
Right, lowest part of the dip. That's a good way to think about it.
What's the difference between the relative and the absolute? Like,
So this is absolute because there's 1.
oh,
And because there's 1 of each, that's what makes these relative.
okay.
Okay? That's how it goes, right? All right, let's look at this one. So we're going to use the table and graph to estimate the extrema of a function that relates to the number of hours since midnight, x, that's what our x value is. Number of hours since midnight is our x, to the number of posts being uploaded, y. The number is in hundred thousands. So when I get these numbers over here, what do I have to multiply it by if I want the actual number? 100,000, right? So we're going to do that as we go through with these order pairs. Last period, I was messing this up like crazy because I hadn't solidified in my head. It says 100,000s right here, right? So we are going to multiply all of these times 100,000. So all of these y values will multiply by 100,000. Okay? We're going to talk about the max and min. Okay? And then we're going to talk about the relative max and min. Okay? So the maxima is the first thing we'll talk about. So the highest point. What's the highest point on this graph? What's the x value of the highest point? Right? You can look over here. You could also look over here, right? But that goes to 24. So it's got to be the highest combo between x and y. So I think it's probably easier to look at the graph right there, right? What's the x value right here? 12. So let's just write it as an order pair. 12, 12, comma. What's the y value? So at 12 right here, our y value is 11.5. I'm going to take that 11.5 and multiply it by 100,000. So I'm going to show you on the calculator. 11.5 times 100,000. So what's that number? Who gets scared looking up here reading that number? Like you always hated reading numbers? Kate? She gets very scared, I know. Yeah. It's okay, like if it freaks you out reading big numbers, who cares? Like you just 1,150,000. Okay, that's what that one is. 1,150,000. Okay? So that's the highest point on the graph. Now what's that mean? That's how many posts there are at what time? What's 12? What's another way to say 12? 12 hours since midnight. High noon. Right? Noon. So minima, the lowest point on this graph is what? Right here. For what? for 1.8, right? Given the graph. So we multiply 1.8 times 100,000. What do we get? We'll do it just so we make sure. 1.8 times 100,000, 180,000. So at 4, oops, can't write in highlighter. At 4, we get 180,000. Okay, what time of day is 4? AM, PM? At 4 a.m. Does that make sense that there are not many posts at 4 a.m.? Right? Middle of the night, everybody's sleeping hopefully at 4 a.m. unless you're an insomniac. Okay? 4 a.m., 180,000 posts being made. Do you guys agree with this graph that at noon, that's when the most social media posts are made? At lunchtime? Maybe at lunchtime, right? What's another huge time where you guys are posting? Like after dinner, you're laying in your bed doing homework or whatever, like 10 p.m. How many people go to bed after midnight every night? That's not too bad. Fourth period, like 10 kids raised their hand. I was like, you guys got to get... You know the most important time for you guys to sleep? Right now. Nap time, right? I had a student teacher last year, and I had 4th and 5th off. I took a nap every single day. It was amazing. Loved it. Anybody take naps in the summer? Right? You're a kid and you fight taking naps, and then once you get a little bit older, you relish a nap. It's amazing. I don't remember where I was heading with that. That's okay. Totally forgot my line of reasoning. I distracted myself. It's very impressive. All right. Next, we're doing relative. Relative max, so the second highest max. So second highest max is right here. What's that order pair? So that looks like 16, 10.2. So 16, 10.2. So if we do 10.2, we get 1,020,000. What time of day is that? 4 p.m. 1 million. School's over. Makes sense. There'd be a surge in social media posts. Then we do relative min. So our second lowest minimum points right there. That order pair is 14, 9.1. So relative min coming up. Was that 14 and I already forgot? 14, 9.1. So 900 or 910,000 would be 9.1. 14 is what time? 2 p.m. So maybe that's in between classes. Kids hammering away on their phone, like all of you do. Okay? So interpreting a graph, you could have to interpret a graph. All right, so just a whole bunch of verbiage going on here. You write as x approaches infinity, right? That means as x approaches infinity. X with the arrow and infinity. Negative infinity, same damn thing with a negative in front. Like that. F of x is really y, so you can't write y, but you can think y. So you can write f of x equals y over there if that helps you to remember that. Not a bad idea. So f of x increases without bound. That means it goes on forever. The number that goes on forever is infinity. And if it decreases without bound, that's negative infinity. Decreases forever. So you guys haven't really done this before, because when you were in Algebra 1, we didn't have the new textbooks yet. Like next year's juniors would have seen this stuff from the new textbooks, but you guys haven't seen it yet, so it's brand new to you. So if we look at this graph right here, as x goes to infinity this way, where's y always? Because this graph is right here. What y value is that? 2, right? So you could say f of x is approaching a specific value like 2. Could be any number there, right? It depends on the graph. So that is a nice segue into that problem, because as x goes to infinity this way, y is always 2. Everywhere along this line, it's always 2. Okay, as x goes to negative infinity, it's still always 2 everywhere along that line. That's why both of those are 2. Okay. On this one, as f of x goes to infinity, where's y going? Because this arrow points up, right? Y also goes up forever. So what should I write in this blank spot? Infinity. Good. Okay. So as x goes to negative infinity, goes this way forever, y is also going negative infinity. So they're both negative on that one. So both negative on that one. Totally depends on the line. All sorts of stuff can happen. We'll get crazy graphs where it's got like these things called asymptotes, and it'll go like this in the middle, and then the sides will go like that. So later on in the year, all sorts of craziness will happen. So if we look over here, right, as x is going to positive, where's y going? Negative. Good. Does that mess anybody up drawing the infinity symbol? Raise your hand if it messes you up. So it used to mess me up a lot more than it currently does. I mean, mine are good enough now. The way I figured it out is if I start in the middle and I go down first through that middle and back around, that helps my brain. Like, it's something about crossing midline in your brain is a weird concept. And if you, it's a sign of a little bit of a challenge, right? Like I'm a little dyslexic, so making stuff like that messes with my head. And I have to literally practice. I practice writing infinity so I don't screw it up. Because I have to teach it, right? And if mine looks like an 8, that's not good. Okay, next one. As x goes this way, what's y doing? It's going up forever, right? Because this arrow shows me going up forever. So it's got to be positive infinity, yes. So we're going to talk about end behavior with the flight of a drone. So end behavior is x goes to negative infinity. Does x go to negative infinity? Where's the graph stop? So we could write our end behavior like as x goes to 0, f of x goes to what? Right? So as x goes to 0, it just stops right there, right? So as y's going down here, where's what? What's y do? Also stops at 0. So as x goes to 0, y also goes to 0. What does that mean? At 0, 0, where's the drone? Don't make it hard. On the ground. It's just on the ground, right? You haven't launched it yet. I learned today for the first time, never knew, it's called a control deck, the thing you hold on with a drone, right? So if I have a drone, I bought it like Home Depot or something, can I fly it to Boulder? No. How far can I fly it? Maybe 100 yards, 200 yards. I've never owned one, so I don't know. But I imagine I can't fly it like over to Highway 36 over there, right? I could probably fly it across Campus Drive and let it hover over there, right? But eventually it loses the signal between the flight control deck, the control deck, and the drone. Now, if you have a military one, it goes forever. Okay? So as f, now how about this? As x goes to infinity. That was kind of a sideways one. As x goes to infinity, what's f of x do? Also goes to infinity given the graph. Is that realistic? Eventually the drone runs out of power, right? So it can't go up forever. It also can't last forever. You're limited by the battery and the distance from the control jack. So it limits our battery and distance from control deck. So you have to write some stuff, right? So I know you understand the graph and what it means. You can write it as it appears, right? Like this top one here has to be as x goes to 0, y goes to 0, because the drone's on the ground right there. This one, it goes forever, both this way and this way, but that doesn't make sense. That can't happen in reality. So you need to tell me something about that. Like your drone doesn't last forever. Battery will eventually die. And then it crashes, and it's expensive when they crash. Here's your homework right here. Get a move on. I checked a lot of you guys on Friday for the homework. Those that I did not get to, I will come around and check. Let me stop my video.